Welcome, guys. In this short video, we are going to study the concept of p-values. In our previous video, we conducted our hypothesis tests and based our results on using significance levels, alpha. So for instance, let's assume that you are conducting a hypothesis, null hypothesis being that mean is equal to 25 against alternative hypothesis mean is not being equal to 25. Then let's assume that you collect your data and your sample mean was equal to 27, let's say. And let's assume that this is null distribution. So this is distribution for x bar minus mu naught minus 25. Let's write it down in general terms, minus mu naught over sigma over root of n. So this is standard normal. And we know if we are conducting our hypothesis test on, let's say, of 5% significance level, then cutoff points for two-tailed test or critical values for two-tailed test are minus 1.96 and 1.96. So a sample means that are going to result in test statistics that are right to greater than 1.96 or less than minus 1.6. 1.96 are going to correspond to rejection region. Now let's assume that this x bar corresponds to test statistics that is equal to 2.02. Okay, since 2.02 is greater than 1.96, we are going to reject. So our results are going to be reject H naught on 5% confidence level, or on 5% significance level. Now let's assume that you have other sample and sample mean this time is equal to 50. And as you can see, this provides much larger evidence against our null hypothesis of mean being equal to 25. And let's assume that this corresponds to some test score, test statistics that is equal to, let's say, 3.96. So 3.96 is far to the right from our critical value and from test statistics in previous sample. So our results in this test for this sample then are going to be also reject H naught on 5% confidence level. So as you can see here, you might have a feeling that we are losing some information here. So our results for both of these tests are the same on 5% confidence level. However, this sample here provides much more evidence against H naught. So we need to quantify that. We need to quantify how much evidence does sample mean provide against our null hypothesis. And we can do that using p-values. So the p-value associated with an observed test statistic is the probability of getting a value for that test statistic as extreme or worse than was actually observed relative to alternative hypothesis, given that null hypothesis is true. So test statistics that yield small p-values should be interpreted as evidence against H naught. So meaning that if you get small p-values, then you should reject your null hypothesis. More specifically, if the p-value calculated for the test statistic is less than or equal to significance level, the null hypothesis can be rejected at alpha level of significance. Or put another way, the p-value is the smallest alpha at which we can reject H naught. All right, so let's take a look at the following example. So given H naught mu is equal to 494 being tested against alternative hypothesis mean not being equal to 494, so two-tailed test, what p-value is associated with the calculated test statistic? with the calculated test statistic, which is equal to 0.60. And how should it be interpreted? So then p-value is the probability of getting as extreme result or worse. So it means that it will correspond to probability of test statistic being equal to 0.60 or greater than 0.60. Since this is two-tailed test, then test statistic values that are less than minus 0.60 are also considered as extreme or worse. Since the reasoning is following, let's assume that you are testing null hypothesis mean being equal to 50 against null hypothesis against alternative hypothesis mean not being equal to 50. Then let's assume if your x bar is equal to 60, then result of getting x bar that is equal to 40 can be considered as extreme as getting x bar 60, since the distance to mu naught to mean in null hypothesis is the same from 60 and from 40. For instance, let's say here is your mu naught, and let's assume that x bar is equal to 60. Then let's assume that another x bar, if it is equal to 45, then since distance from 45 to 50 is only 5, and from 50 to 60 is 10, then this result is not as extreme as this one here. Okay, so since we are using two-tailed test, then we should also consider probability of test statistic being less or equal than minus 60, minus negative value of test statistics that you have obtained. Since sample means that are too small or too large are going to give you an evidence against your null hypothesis, since you are testing against alternative hypothesis of mu naught not being equal to 494. Okay, so probability of that, then using software, we can probability of that being equal to 0.27, multiply that by 2. So our p-value is equal to 0.548, which basically means what is the probability of getting as bad or worse sample than we got here if we assume that null hypothesis is true and hypothesized mean is equal to 494. So as you can see here, this probability isn't so small. So probability of getting like this as usual sample is equal to 55%. So it isn't very unlikely, meaning that you shouldn't reject your null hypothesis here. And in fact, you will not reject null hypothesis here at alpha is equal to 0.05 significance level, since this probability here is much greater than your significance level. Okay, so as we can see from graph here, this is our null distribution. Then p-value is defined as the sum of areas in the following two tails. This here is a test statistics that corresponds to the sample mean from your observed data. Then when you are when we are using two-tailed tests, then we need to multiply one of these tails by 2. Okay. All right, guys. Now that is going to conclude our video on p-values. Also, let me briefly mention in case if we will have a one-tailed test, as we said that we are not going to consider one-tailed test. So anyway, in case of one-tailed test, then p as extreme results are the results that are let's say if you are testing null hypothesis of mean being equal to 25 against null hypothesis alternative hypothesis mean being greater than 25, then evidence against your null hypothesis are only x bars that are going to give you big values of your test statistic. So then in this case, you shouldn't multiply your area in your tail by 2, since only values that are greater than some critical point here are going to be served as evidence against your null hypothesis. So for instance, if your X bar is equal to 30, and let's assume that it corresponds to test statistics that is equal to 2.5, then you calculate this area here, and that will be your p-value, unlike the case of two-tailed test when we need to multiply our probability by 2. All right, guys, now that's going to conclude our lecture on p-values. Thank you for watching.